In this lesson, we're going to do a little more with vectors. So another way we can specify the direction of a vector instead of slope is using a direction angle. The precise way to specify the direction of a vector is to state its direction angle, not its slope. So this is what we're going to focus on when we want to state the direction of our vector, is using direction angle. Now to find that, our vector will have direction angle will be, with direction angle, is the magnitude of the vector, cosine of the angle. Magnitude of the vector, sine of the angle. So where that comes from is, if this is our vector in standard position, we can drop down here. Alright, and this is going to be, if we have the magnitude of v, so the magnitude of our vector here, this y component, or this vertical component, is the magnitude of v, sine of the angle. The angle is right in here. Okay? So this is our vertical component. Now our horizontal component is going to be over here. We have the magnitude of v, cosine of the angle, and that's going to be our horizontal component. Okay? So we know that cosine of theta is adjacent over hypotenuse. So our adjacent is our x direction over our hypotenuse of the magnitude of v. So we multiply over, so then x is the magnitude of our vector cosine of theta. Now sine of theta is going to be our y. So here we had our x, this was our y, is y, so opposite over hypotenuse. And there we have y is the magnitude times the sine of theta. And that's how we get, if our vector is xy, that's how we get what we have above. Alright? Simple enough. So now, let's look at some examples. So I want to find the component form of the vector v with magnitude of 15 and a direction angle of 40. So we want to try and stay away from drawing our triangle every time, but for purposes of seeing it to start, we'll draw a triangle. This is our vector, the magnitude of v. And we know the magnitude is 15. And we know it has a direction angle of 40 degrees. So if this is our x, and this is our y, v is our magnitude, cosine of the angle, magnitude, sine of the angle. And then you can put that in our calculator, making sure we're in degree mode. We got 11.491, 9.642. So then this is the component form, okay, using our direction angle. So I want you to try the second one on your own. Be sure to rationalize if possible. So go ahead, give that one a try. Now let's look at another example. So this is going to be converting from component form to magnitude and direction angle. So if we're given we want to find the magnitude and direction angle for this vector. So what we did before, we computed the vector. Now we want to go backwards. So for magnitude, as we learned in the last lesson, the magnitude of u is going to be our x squared plus our y squared. So that gives us the square root of 52, which is going to be 2 square root of 13. So our magnitude is 2 square root of 13. Now we want to find the direction angle. So if we had our triangle, or angle, it's -4, 6. So this is -4, goes up 6. Okay? So we can find this angle just like we found for any other right triangle. We have our opposite and our adjacent, so we can use tangent inverse of our opposite over adjacent, and that's going to equal -56.310 degrees. But now -56.310 degrees is over here. So that's not the angle we're looking for. Tangent is also negative down here as well as up here. So since it's restricted, so we have to take into account that restriction, add 180. So therefore, our theta is our -56.310 plus 180. So we get 123.690 degrees. So here we have our magnitude and our direction. Alright? Now we use tangent. There are actually 3 different ways to find direction angle. Our 3 ways are tangent inverse, cosine inverse, and sine inverse. This one here is our most used. Now we still want to know the other ones, but this one is going to be our most used. So let's look at an example. We want to find the magnitude and direction angle for the vector -3, -5. So our magnitude is going to be the square root -3 squared plus -5 squared. That's going to be the square root of 34. So this is our magnitude. And now we want to find the direction angle. So our direction angle is tangent inverse of y over x. Put that in our calculator, and we'll get 59.036 degrees. And again, we got to make sure tangent is restricted. So since both of these are negative, we know it's pointing down here, but the angle we got is up here. We want this one, so we add 180. So now our angle, theta, is 239.036 degrees. And that'll get us all the way around back to that angle. Alright? So now, what if I want to convert from one form to another? This is just a nice chart to kind of get us seeing it. We want to convert from direction angle to component form like we started at the beginning. We know x is our magnitude times our cosine of the angle, y is our magnitude times our sine of the angle. Going the other way from component form to direction form like we just did, our magnitude is the square root of x squared plus y squared. And our theta is going to be tangent inverse of y over x. Okay? So something we might want to recall that is going to come up a lot is bearing. Bearing is the angle measured from due north. This is also going to be called heading. See, compass heading is going to be the direction from the due north. So if you want to know what a bearing of northeast is as a trig angle, think of your compass. We have north, south, east, west. Okay? So if we're bearing northeast, that's going to be 45 degrees. Okay? Now if we're looking south, southwest, north, east, south, west. So if we're doing south, south, this here is southwest. South-southwest is going to be half of that. Okay? So it's 45 between here divided by 2. So it's going to be 180, which is north to south is 180 from here to here. 180 degrees plus that 45-degree angle divided by 2. So therefore, it's 247.5 degrees. If we want to go 20 degrees south of west, we go over west and you go 20 degrees south. So that's going to be 180 so look over here. Here's west. We're going to go south of that. 20 degrees. You take your 270 degrees. So you go from here all the way to there. We can subtract 20. Okay? And if we want to go 10 degrees north of west, it's a little bit different. You do 270 degrees and we go 10 degrees north of that. So you want to practice some of these on your own to make sure you can convert. Okay? Let's look at an example that uses this. So we have an airplane that's flying at a bearing of 335 degrees at 530 miles per hour. We want to find the component form of the velocity of the airplane. Okay? So we can draw ourselves a picture. So they're flying at 335 degrees bearing. So this here is 335 degrees. What's left over is 25 degrees. Okay? So our direction angle, we want to convert to a trig angle. So we had 335 degrees, we want to know the trig angle. So we want to know this angle here. Okay? So that angle there is going to be 90 plus the 25 degrees. So 115 degrees is our direction angle. Okay? Now I want to find the magnitude. The magnitude is given to us. Our magnitude is going to be our speed. So our vector for the speed of the airplane, I'll call it v, 530 cosine of 115 degrees, 530 sine 115 degrees. Put that in your calculator and you'll get negative 223.988 and 480.343. Okay? Simple enough. This next example I want you to try on your own. This next example says an airplane is flying on a bearing of 170 degrees at 460 miles per hour. Find the component form of the velocity of the airplane. So it's just like that last problem, and see if you can get 79.878 negative 453.012. Okay, so take a few minutes to try and see if you can get that one on your own. Alright, so now I want to look at a word problem. So we have an airplane that's flying on a compass heading of 340 degrees at 325 miles per hour. There's also a wind blowing with a bearing of 320 degrees at 40 miles per hour. Find the component form of the velocity of the plane and find the actual ground speed and direction of the plane. So let's start by drawing some pictures. So our plane, right here, is flying at a bearing of 340 degrees. So they know there's 20 degrees left over here. Okay? And we know that we have wind that's at a bearing of 320 degrees. Okay, so the plane has a magnitude of 325 miles per hour, and the wind has a magnitude of 40 miles per hour. So I want to find the component form of the velocity of the plane. So let's look at just the plane first. So our plane we'll call P. It will be our magnitude, which is 325, cosine of the angle. So the angle is this whole angle there. So that's 110. So it's 325 cosine of 110 degrees, 325 sine of 110 degrees. So as a decimal, that's going to be negative 111.157 and 305.400. So I'm going to store this first part as A and store this second part as B. So now I want to look at the wind. So my wind has a magnitude of 40 miles per hour, and the angle is 90 plus 40, which is 130. And put that in the calculator. We get negative 25.712, which I will store as C, and 30.642, which I will store as D. So to find the component form of the velocity of the plane, I'm going to take P plus W. So I'm going to add them together because the wind has an effect on the plane. So I'm going to do P plus W, which is going to be our A, stored A plus C, and then our Y value parts, B plus D. And that's going to give me negative 136.868 and 336.042. So we can see the wind has shifted the plane just a little bit. Okay? So now, it also asks find the actual ground speed and direction of the plane. So to find the actual ground speed, I'm going to take the magnitude of the component form. So the magnitude of P plus W. Take the magnitude of that, and it's going to be our A plus C part squared plus our B plus D part squared, and that's going to give me a magnitude of 362.846 miles per hour. Now I want to find the direction angle. To find the direction angle, I can use tangent inverse, and I can do y over x. So it'll be that B plus D part over A plus C part, and that'll give me approximately negative 67.839. But I have to remember my plane's going this way, and I just got an angle that's down here, so we're going to have to add 180. So my angle is going to be 112.161, which is a bearing of 337.839 degrees. So now I have my magnitude, my bearing, and this was the actual direction of the plane. Okay, so that is going to be it for this lesson. Make sure you're using stored values for all of these. Make sure you're storing the right ones and adding them together correctly. You want to take into account what your plane is flying and also what the wind is doing. And you want to make sure that you're converting from a bearing angle to a trig angle. You always want to convert to the trig angle, otherwise it will not work. Alright, that is it.